is that sometimes when you design a finite state machine, you have your actual, like, how it's working is in your head, and that may not be the most efficient way, because it may be that some states really are kind of the same, and you could do it in a more efficient way. So when you map it out, when you draw your state diagram, you put all the states, like if it's a vending machine, maybe it's, I put in a dime and a nickel, and then the question is, well, is that really the same as if you put in 3 nickels? And maybe it is, maybe it's not, depending on what you have it do. And so the technique that we're going to go through is a way to minimize your design so that you have as few states as possible. So you look at your you look at your states, and you are going to partition it. And a partition is just a set of states. And when we're all done, everything that's in the same partition you can treat as one state. And so when you start your first partition, and he wants you to label your partition so that you can see what you've done on each step. So P1, our first partition, is going to be all of our states. So we put them all in there: A, B, C, D, E, F, G, H. And then our next partition is we look at our output and we divide it up so that things that have the same output are in the same partition. And by the same output, if they have 2 outputs like we do here, Z2 and Z1, we would mean they have, everything is the same. And so for our second partition, we will put together everything that has 0, 1 as an output. So that would be states A, B, D, F, and G. So they'll be one group. And then everything that has 1, 0 as an output, so that would be states C and H. And then the only thing that we have left on this one is the output 1, 1, and that would be state E. So we divide it first into that. And now we look at what are called the successors. So we want to see what is the next state. And you can start with either 0 successors or 1 successors. We'll start with 0 successors. So we want to see what is the next state when W equals 0. So when I look at states, I'll start with this first group, A, B, D, F, and G, and I'll see if I need to split it up. So I see when for state A, when W equals 0, then my next state is E. So the 0 successor for A is E. So we'll start with that. The 0 successor for B is also E. So they have the same 0 successor, so they'll be the same. And then I'll go to D. Its 0 successor is also E, so we can keep D in there. F, its 0 successor is H, which is in a different partition. And so F needs to be in a different group. And G's 0 successor is C. And if you look, C is in the same partition as H. So F and G are both going to this CH group. So we can put them together. So F and G go together. And so we divided A, B, and D. We divided this first group up into A, B, and D, and F and G. Now for the second group, CH, we have to see where they go. So C goes to H. And H goes to C, so they stay in the same partition. And anything that's all by itself, you don't need to check. It's going to stay all by itself. So we checked the 0 successors. Now we'll check the 1 successors, and we'll go on to P3. That was P3, sorry. That was P3, this is P4. Okay, so for P4, I'll check A goes to F. And I'm looking at the 1 successors. B goes to G. And D goes to E.
D goes to F.
D goes to F, thank you. Am I just misreading it? I am just misreading it. Okay. Oh yeah, I'm looking at the 1 successor. Thank you. D goes to F. So they all go to the same partition, so they stay together. Okay. F goes to F. And G goes to G. And those are both in the same partition, so they stay together. C goes to B, which is the first group. And H goes to A, which is also in the first group, so they stay together. And then E's by itself, so it stays together. Now you just pick one out of each group to represent that group. So I'll choose A and F and C and E, and those will be my states. So I'll have present state and next state and output. And so my present state will be A, C, E, and F. And for A, when W equals 0, my next state is E, and that is one of the states I have here, so I'll use that one. When W equals 1, my next state is F, and that is one of my states, so I can use it. For C, when W equals 0, my next state is H. H is in this group, which I called C, so I'll put C. And for C, when W equals 1, my next state is B, and B is in this group that we labeled A. And for E, when W equals 0, my next state is E. When W equals 1, my next state was D, and that is the group that we call A. And for F, when W equals 0, my next group is H, and that one we called C. And when W equals 1, my next group is F, and that one we called F. And then our output for A is 0, 1. And for C is 1, 0. And for E is 1, 1. And for F is 0, 1. Alright. Do y'all have any questions on that? And if not, I'm going to give y'all one to practice. So hold on just a second.